Hey all, welcome back to my channel. So in the previous session we have discussed about what is dynamic arrays and how we are going to use the methods in dynamic arrays, like in order to increase the size of the array or in order to delete the array. So all these things we have discussed in the previous session. If you didn't see that, I'll link that in the description box. You can go check it out there. So in today's session we are going to discuss about associative arrays. This is one type of dynamic array. Okay, so if you are new to my session, consider subscribing this channel and hit on the notification bell also. Also, give me a small like, which will be a kind of motivation to me. Okay, so coming to associative arrays. So, as I told you, this is one type of dynamic array. Basically, arrays are categorized into two types. Like one is static, another is dynamic. So, again in dynamic, you are having again three kinds like dynamic arrays, another is associative arrays, and another is queues. Okay, so these three are also type of arrays. Okay, but they will be differing based on the usage and based on the methods that we use in this particular arrays. Okay, so in today's session we are going to discuss about associative arrays. So what is the new need of associative arrays even though we are having this dynamic arrays? Okay, so, dynamic arrays are used for a continuous collection of variables whose number changes dynamically. That means when we are declaring a dynamic array, like for example, if we have declared the how are we going to declare the dynamic array? Like for example, int array of something, and then we'll be declaring this array equal to new of 4. Okay, now if we have declared it in this way in dynamic array, now what happens? All the four elements are allocated. Is it or not? That means 0, 1, 2, 3. That means four memory locations are continuously allocated. That why? Because when you are going to assign the values, what you are going to do? 0, 1, 2, 3. That means all the elements are continuously allocated here. Okay, this is the thing in dynamic arrays. But in case of associative arrays, it is an extension of dynamic arrays, we can call it. Like whatever that is not there in dynamic arrays, we are going to make it in case of associative arrays. So the first thing is in dynamic arrays there is continuous collection of variables. That means when you are assigning something, you are assigning it in a continuous manner. But in case of associative arrays, this is not happening. This is more flexible compared to that of dynamic array. What is the flexibility? Where does this flexibility lie? That means when you want to assign a particular, for example, if you see here, it is having four memory locations 0, 1, 2, 3, and when you want to assign the elements, you have to assign it continuously like 0, 1, 2, 3. All the elements you have assigned it at a time. But in case of associative array, what happens means when you want to you assign only for this value, and when you want to not use the remaining values, you can do that. Okay, that means when you want to assign the value into the second memory location, you can do this by giving ARR of 2 equal to 2. Okay, in this way you can do that. Means whenever you want to assign only for a single memory location, you can do that in case of associative arrays, but this is not possible in case of dynamic arrays, we can say that. Okay, and also mostly we'll use this associative arrays when the memory is very sparse. Sparse means very large. That means when we don't know how, for example, when we are designing some memories. Okay, when we are designing a memory, there should be a lot of allocations to be needed. Like when you in memory, we are having various allocations, like for arithmetic logic unit or for some other things, for registers. For all these things we need memory allocations, right? But when we are designing, we don't know how much memory we needed. Is it or not? So in such cases, that means when you are designing a circuit whose memory can't be estimated at the starting time itself, and also you can estimate that the memory that you need to allocate should be large. Okay, so in such cases you will be going for associative arrays. When you don't know how much memory you should allocate, and also you estimate that the memory is very large, So in these two cases you will be using this associative arrays. And also this is one of the advantage, this is one of the flexibility or extension from dynamic arrays, because in dynamic arrays, even though we are using it, we we should at least give the, when you are allocating the memory, you should at least allocate the memory during the simulation time itself. Okay, even though you are not allocating it at the compilation time just like static arrays, but at least you should allocate the memory during simulation. But in case of like associative array, that is not the case. That means here in associative array, the memory is allocated when you are calling that particular array. Okay, right? Okay, I'll when we are explaining about examples, like example on this associative array, we'll be talking more about this memory allocation and all. So as for now, you just remember that when we are using a memory which is very sparse and we don't know how much memory we are going to allocate, so in such cases we will be going to associative arrays. So this is one extension from that of dynamic arrays. And then, okay, one more advantage in associative arrays is we can use any kind of data type in case of associative array. That means for indexes we can use any kind of data type. What is it basically? That means until you have seen now, like we have seen static arrays, right? Dynamic arrays. So in all these dynamic arrays, what are the indexes? You see, all the indexes are numbers. That means when for static array you are going to do it like array of 5. Now what happens for this array of 5 when you are going to give it? So 5 memory locations are being created, right? 2, 3, 4, 5. So 0, 1, 2, 3, 4. This is index, right? And this index is in number format for static. And when you are going for dynamic, also the same thing. New of 5. Okay, these are the two allocations for dynamic array. Here also, even though you are declaring it during simulation also, but still the indexes are same, like 0, 1, 2, 3, 4. That is, this is also number format. That means here you are only using int data type or integer data type. Is it or not? You are only using numbers for both static as well as dynamic array. But in case of associative array, that is not the case. That means the index can be of any data type. Any data type means it can be either of number like integer, or it can be float data type like real numbers, or it can also be a string data type. Okay, which is not at all possible in case of static as well as dynamic also. That means here the indexes can be of string data type also. We'll see the example how this is going to happen. Okay, this is one of the advantage in case of associative array compared to that of static and dynamic array, right? Clear? So this is about the associative array, right? And also associative array allocates the storage only when it is used, unless like in the dynamic array we need to allocate memory before using it. That means if you see in the before example here, even though we here for static array, the memory, how the memory allocation will be for these three, let us see now. In static array, the memory allocation is done during the compile time. Okay, during compilation only. That means as soon as you are declaring the array and when it is compiling, the memory of 5 locations is being allocated in case of static array. In case of dynamic array, what is happening? Even though it is not allocated during compilation time, but during simulation it should be allocated. That means whether you are using it or not, that is not the case, but it has to be, it has to allocate all the 5 memory locations during simulation time. Okay, even though the difference between time exists in case of static and dynamic, but still at simulation time the memories need to be allocated. The memory that you are creating here by using a new keyword, it needs to be allocated during the simulation time, but that is not the case in associative array. So in case of associative array, when the memory will be allocated, when you are using that particular array, at that time, at that point of time only the memory is being created. Until and unless you are not using the array, the memory won't be created in case of associative arrays. But in dynamic array, even though you are not using the memory location also, when you are simulating the code, the memory is automatically allocated. And in static, obviously at the starting itself, like in during comparison time only, the memory is allocated. So hope you got the difference between how the memory is being allocated in static, dynamic as well as in associative array. Okay, so this is what happening. So if you see here, when you have discussed about what is the difference between static and dynamic arrays, I have told you here, so the simulation is very slow in case of dynamic array, because during simulation itself it needs to create the memory as well as it need to assign the elements, and then it needs to run. So all this is taking during the simulation itself. So the running period of dynamic array is slow when compared to that of static array, because in static array, before only we are declaring the size of the array, and this memory allocation is done during the compilation time itself. So now when we are simulating the code will be running much faster compared to that of dynamic array. But here in associative array, it is more slower than that of dynamic array, because at least in dynamic array, during compilation time the memory is during simulation the memory is being created. But in associative array, that is not the case. Whenever we are calling that array at some point of my code, at that time only it need to create the array, it need to assign the array, and it need to run that particular thing. So here it is much slower when compared to that of dynamic array. Okay, so that is the thing, is not allocated, as the memory is not allocated immediately, thus the allocated memory is not continuous in nature. Obviously, as I told you, in particular, if you see it in dynamic only, in dynamic the memory is continuous. Why? Because we are allocating it, even though we are allocating it during the simulation time also, but still we are allocating it like continuously. If you see in the before example here, new of 5, that means all the 4 locations are allocated here. Okay, but here, since the allocation is not done during the simulation time also, so the memory is not continuous in case of associative array, which makes it slower than that of dynamic arrays. That is what I told you. And one advantage is, in associative arrays the index can be of any data type, that it can be of either integer data type or real or string, any kind of data type. This is one advantage in case of associative arrays. Got my point? So let us see how we are going to declare the array, how we are going to use the array and all. Okay, so this is the syntax of array declaration of associative array. That means data type, array name, index type. This is main important here. Why? Because as I already told you, here in associative arrays the indexes can be of any data type. So before, in if you see in static arrays and dynamic arrays, we didn't use this index type. Why? Because by default they are always using only numbers, that means integer data type. But in case of associative array, there is an option that we can choose any kind of data type. So there is no default case, because we have to choose it whether it is which data type it is. So that is why you should mention surely which index type it is, like whether it is the integer index type, that means whether the indexes are of integers, or the indexes are of float values, or the indexes are of string data type. You should particularly mention it. Okay, so data type, array name, index type. Okay, right? And here if you see module db, if you see the code here, so see, this is how you will be declaring associative array. Okay, int array of 1 int. So if you see here, this is my associative array, okay, which is of int data type. That means the elements inside this are int data type. Okay, and the indexes are also int, that means the indexes are also numbers. Okay, and if you see my second thing, this is my array 2, which can hold integer data type elements. That means the elements inside this particular memory locations, they are of int data type, but the index is of string data type. Okay, that means the indexes should be of string data type. And if you see my array 3, here the elements are also string data type, whereas the index is also string data type. So let us see what is the meaning of this particular thing. If you see here, initial begin array of 1. Okay, as I already told you, this array of 1 is of it can hold int data type as well as the index is also int data type. That means what is happening here is here, okay, it is having two memory locations. From here if you see 1 and 6, okay, only 1 and 6 are created. That is what the advantage is here, because if you see, this is not possible in case of dynamic array. Okay, here the 1 is 22, that means the one location. When you see it in a dynamic array, when you want to initialize in such way, all the memory locations are being created: 0, 1, 2, 3, 4, 5. Okay, and the 0th is given as 22, the remaining all are assigned as 0, and the sixth location nothing but the fifth location is given as 34. This is happening in case of dynamic array, but in case of associative array, as I already told you, whenever we are going to call that particular memory location, only that memory location is being created. So here the first memory location will be holding the value of 22, and the second memory location will be holding the value of 34. That's it. Okay, first and sixth memory location will be holding the value. If you see here, this is of int data types. Okay, and these are the elements that are there in that particular locations of 1 and 6. Okay, so when it comes to second, if you see here, I am taking the second one of, if you see here, the index is of string data type. Now what is happening here, this is my index. Okay, my index name is Ross and Joy. Okay, so the Ross is holding the value of 100 and Joy is holding the value of 60, because these are of int values. Okay, so numbers, right? And when it comes to third, if you see, what is the third? Both are strings only. So if you see here, the first is apples. That means this is my apples and this is my pears. Okay, so my apples is holding a value oranges. Okay, and my peers is holding a value of 44. Now you will get a dot. We are calling it a string, okay, but we are using number. If you see this, we have given this within the double quotes. That means this 44 is also an alphabet. As I told you, strings will always be using ASCII characters. So according to ASCII characters, every word or every number will be having its own ASCII character. So that is why, based on that, this is also, it is just a 4 4. Okay, so these pears is holding this 4 4 and apples are holding this oranges. Okay, clear? And when you want to display this, everything will be displayed in this manner: array 1, array 2, array 3. Okay, array 1 equal to percentage p, all these things. Okay, and end module. Clear? So this is how the display will be done in case of associative array, right? Yes, so let us take one more example for you. Okay, module associative array. If you see here, my it is my data type is int, number of cars. This is my array name. Okay, string. So my index is of string data type. Okay, and what are the elements it could hold? It could hold int number, int, which is nothing but integers. So if you see here, initial begin number. Okay, I am just giving the assigning the values. So if you see here, what is my indexes here? Hyundai, Suzuki. So these are my indexes. And Tata. Okay, this is my index. So what is my Hyundai holding? 2. Suzuki 1. Tata 3. So these are the indexes that is holding. This particular memory location is holding. Now when I want to display the number of cars, that means when I want to display this particular thing, then I am going to do it like this. Okay, number of cars equal to percentage p, number of cars, nothing but whatever that is there in number of cars. Okay, everything will be displayed as it is. Okay, but when I want to display only particular index, okay, for example, I want to display only what is there in Suzuki. If you see, number car of Suzuki. Now what happens? What is there in Suzuki? It is what is the element that is holded by Suzuki? 1. So only that element will be displayed. Okay, if you want to display only a particular value, particular element of particular index, you can do it in this way, like number of cars of Suzuki. Okay, Clear? So this is how you will be writing the associative array. Here one more thing is, right, here as I told you, the data type is very important in case of associative array. So for example, when you are, as I already told you, basically this associative arrays in real time they will be used in order to hold some when you are designing some memories, or when there is a case when there is a, we don't know about how the memory, how much memory we are going to use. Okay, in those dilemma kind of situations we'll be using this associative arrays. So in such cases there may be a thing like we don't know which type of elements, which type of index can also be there, like what type of, whether we want to use a string data type, or whether we want to, whether that index should be of string data type, or whether the index should be of number data type, or else like this we don't know. So in such cases what you will do is you will just be using number car of star. So here if you are giving the star, that means it can hold, it can be of any data type. Okay, because when you are giving string, that means the index can be only of characters. Okay, it can't be of like integers. Okay, when you are giving it as int, then the index can only be of integer but can't be of string. Okay, that means whenever you are giving star, that means based on our application, the index can be of any data type, like whether it can be string, whether it can be integer, or anything. Clear? Yes, that is why mostly we'll prefer star compared to that of string data types. That is why whenever you see any big examples of an associative arrays, mostly you will see this star. Okay, the meaning of this star is it can be of any data type, whether it can be of string, float, or int, integer, any kind of data type it can be. Okay, that is the meaning of this star. Okay, but if you want that to be a particular data type, you can just write the data type instead of using the star. Clear? So, as I told you, why do we have already discussed this point. Why do we need associative arrays? In dynamic array, we need to allocate memory before using it. I already said it. But in associative array, memory is allocated only when it is used. So, until and unless we don't use it, the memory won't be created in case of associative array. But that is not the case in case of dynamic array. Okay, a dynamic array is specific for a particular data type. This is also one more important thing in case of associative array, because dynamic array it can be only used for integers, but when it comes to associative array we can use any kind of data type we need. Okay, and associators are very useful when we want to model memories. That's what I said. Mostly we'll be designing elements which is having a lot of memory. Okay, which needs to be created with lot of memory. So in such cases we'll be using the associative arrays. Okay, so this associative arrays is having certain methods like number, delete of index, exist index, first value, last variable, next variable, previous variable. So just like we in case of dynamic arrays we have seen some methods like size, in order to know the size of the array, delete, in order to delete array, but there are only limited options in case of dynamic array, whereas in associative array, since we are having lot more extensions compared to that of dynamic array, so that is why there is also lot more options in these methods compared to that of dynamic array. Like if you see here number, in order to know the size, basically there you will be using size. You here in associative array you will be using the num. Okay, number, in order to know the number. And delete index, okay, when you want to delete the entire array you can just give delete, and when you want to delete only particular element, like if you see in the before example here, if you want to delete only this Hyundai, then you can do it by using delete index. That means when you have given that particular index name, then only that index will be removed and the entire things will be remaining same. Okay, exist index, that means in order to know whether that particular index is existed or not. That means, and at some point of time when you want to know whether the data memory location is allocated, whether that particular index is allocated or not, whether it is there or not, present or not. So in order to know that exists, that means whether that particular memory location index name is existed or not. Okay, in order to know what is the first variable in your array, in order to know what is the last variable, and in order to know what is the next variable. Next variable means basically where your pointer is at that particular point of time. The next variable next to that pointer is called as next variable, and the previous variable previous to the pointer is called previous variable. In order to know this, you will be using previous. Okay, if you don't understand this also, don't worry, because when you are going to explain, see this as an example, you will understand clearly what is the meaning of this first, class, next and previous. Clear? Yes. So these are associative array methods. Okay, in the next session we are going to explain it clearly with an example, so that you will be easily understood, right? So this is all for today. Thank you.